So this section talks about how extraordinary, how unusual water is. Water is by far the most common and most important liquid on Earth. If I asked you to name liquids, most of the things that you would think of are actually aqueous solutions, right? The ocean is an aqueous solution, it's water. There are very few things that we use regularly that are not aqueous. Things like gasoline or acetone. You have liquefied propane, those sorts of things, vegetable oil, but most things are going to be aqueous solutions. So we know that water is essential for life, right? If you don't have water, you can't be alive, and that's one of the things they're looking for in outer space when they're looking for signs of life. They're looking for water. Water has a low molar mass, and yet it is a liquid at room temperature. Most things that have that small of a molar mass are going to be gases at room temperature. But water is a liquid because it has hydrogen bonding. So water is the main solvent in living organisms in the whole environment. It has a very high specific heat capacity. It's 4 joules per gram, where a lot of things are less than 1 joule per gram. So you add a certain amount of heat, the temperature will rise only a quarter as much as if you added that much heat to something else. And so this allows water to moderate climates. We talked about how the climate in the San Francisco Bay Area is very different from ours here in Fresno. Another very strange thing about water is that it expands upon freezing. Most things get more dense when they freeze. They shrink. But not water. It expands. And so you've probably seen a head of lettuce that looked like this. What happened to this lettuce? It was in that part of the refrigerator that's just a little too cold, right? It got frozen. And then it just gets all nasty like that. There's nothing you can do to fix it. What happens is that the water in those cells freezes and it expands and it bursts the cells. And that like totally messes up the lettuce, right? The same thing will happen if you take a water bottle that's full and you put it in the freezer, or Gatorade or anything. If you don't leave a good amount of airspace in there and you freeze it, it will break the bottle. It'll just pop it right open. This is looking at the boiling point, and we saw a graph similar to this earlier. So here are, we've got group 4 elements, group 7, group, which one is that, 5, and group 6. And so we see this trend here that as we go, these are all compounds with hydrogen, as we go down the periods, the atoms get larger, the molar masses get larger, so the strength of the intermolecular forces gets stronger, and the boiling point goes up. As we go to smaller and smaller, the boiling point goes down. So here we have methane, which is the main component of natural gas, and that has a boiling point like minus 170 degrees Celsius, way, way down there, right? This is a small molecule, and it's also nonpolar. Here we have ammonia and fluorine and oxygen in their hydrogen compounds. And what is special about those 3 elements? E.T. E.T. phone home, right? We have fluorine bonded to hydrogen. This can do hydrogen bonding. We have oxygen bonded to hydrogen bonding. We have nitrogen bonded to hydrogen. That also has hydrogen bonding. And so we see that the boiling points for these guys are much higher than their friends further down in the different periods. And that's all because of hydrogen bonding. I'm not going to test you on water pollution, but I think it's something we should all be interested in, because water quality is important for our health, right? If we can't get clean water, we're going to not be healthy, right? If it's contaminated with organisms, we might get violently ill. If it's contaminated with inorganic things, we might develop cancer or other sorts of problems. So there's two kinds of water contamination: biological contaminants and chemical contaminants. So biological, those microorganisms. This is things that cause hepatitis, cholera, dysentery. You guys ever played the game Oregon Trail? What does everybody end up dying of? Dysentery. Because it was in the water, and it makes you really, really sick, and a lot of people died from it. So these sorts of things will get into our drinking water if animal or human waste is dumped into bodies of water, or say your source of water is flowing near a cow pasture, right? Where it rains and it runs off into the creek, and it's going to take those organisms that are in the cow pies, and it's going to get in your water. And that's why you don't want to drink water out of a mountain stream, because, a bear with some thing in its poop might have, pooped upstream, and you could get sick, right? The good thing about biological contaminants is they're relatively easy to get rid of. Most of them you can kill just by boiling the water, right? So you boil the water. There are also chemical treatments that you can do. Bleach is one of them. I think iodine is another one that's sometimes used. You can get these little tablets to put in the water when you're camping, so to make it safe for drinking. Chemical contaminants are going to result from industrial and household dumping, from pesticide and fertilizer use. So we put pesticides, to control the bugs in the crops, or we put fertilizer on there to help the crops grow better. But then it rains, and some of those substances leach out and eventually get into the water table. These substances are not alive. Boiling them is not going to destroy them. It's not going to boil them away. Most of them are non-volatile. In fact, it could actually make it a little bit worse, because as you boil the water, those substances are going to become concentrated. So then you have to use various types of filters and other processes to get rid of chemical contaminants. And so this is one of the reasons that if you're changing the antifreeze in your car, you should never dump that antifreeze in the gutter, right? Because that's going to eventually make its way into the water supply, and the ethylene glycol that's in there is not something everybody wants to be eating. Another problem with that is that it tastes sweet, and so animals tend to eat it, and then it kills them. So also not a good idea. Any questions?